I'm going to talk about something that's kind of new and novel in the industry, but it's something that we've kind of seen as a use case pop up here and there at Browserless. And it's called hybrid automation. So let me paint you a picture here really quick. I want to give you a simple use case of loading Gmail for your, business or project or whatever. And we're going to look at emails, do some analysis. Something's going to happen. It's up to you. This is where your creativity comes into play. I'm just kind of giving you a scaffold of what's going on and then profit. So yeah, step one, load Gmail. Uh-oh. This is what happens the first time you try to load Gmail with a username and password, if you're me, because I have two-step verification on my Gmail account. So if you're automating this, that's a problem. That's going to cause some issues. And to be honest, like, this is not anything super crazy. Online accounts nowadays are almost always multi-factor auth. If anybody goes through like SOC 2 or any sort of security compliance, that's always the first thing they tell you to do is, hey, two-factor or multi-factor. But that doesn't change the fact that, businesses need sometimes access to external systems. Think about it for HR onboarding or payroll or any sort of thing where you need to put a new user into an account. So programmatic access is great when you can get it. Data, I think, will be kind of eventually treated as a liability in some cases, having too much data. So back to my, thought with, two-step verification, a lot of times you get asked for your code. And, to me, asking for two-factor auth codes or multi-factor auth codes is a red flag. Unexpected notifications really raise a lot of questions when they happen most of the time. It's like, I didn't initiate that. And we see it all the time with scams and security issues and spoofing. So action tends to be more trusted. Like, I knew I was trying to do this, and therefore I'm expecting a notification. So with those, I mean, asking for, again, username and password and saving those in your system to try to automate some task, always going to be a little sketchy. And again, thinking about other vendors out there, software companies that save these, like, that's kind of a liability long term. And I really do hope that gets changed in the future, because the amount of breaches are starting to get, quite frankly, to be a problem. Okay. To reframe what we're going to do here, and this is going to be quick because I want to save time for questions. This talk and the contents within it always bring up a lot of questions, which is great. We're essentially going to build this type of a stick shift, gear shift, not a stick shift. We're essentially building a sort of hybrid automatic, but with a manual transmission. So for those of you that haven't seen this kind of a gear selector, this is in cars that are both automatic and they're manual. So 9 times out of 10, you're going to put it in drive and the car just changes gears. It knows when to do what, and you don't think about it. But there are times when you want to tell the car, hey, you need to be in a lower gear or a higher gear potentially for, I don't know, towing something. Maybe something is broken or needs to be addressed. And so you have to manually opt into like human involvement. Fantastic device, by the way, for anybody that deals with those and, has to drive and maybe tow something. So yeah, that's kind of the metaphor to frame this talk. But essentially what our plan is we're going to capture a video stream of a headless browser. We'll get into that. We'll capture a user's keyboard and mouse events and send them back to that headless browser. And essentially the technology we're creating here is going to operate as almost like a liaison between headless Chrome and end user Chrome. So it's almost like a game streaming. If you've ever interacted with like a PlayStation game streaming or Steam game streaming, it's like something else is running and rendering things, but you're interacting with them directly via a client of some kind. In this case, it's a web browser. But yeah, so big thing here is, even though you might have headless Chrome running, it still renders a display. There still is a display being drawn someplace. It's just that you can't see it. So it's like the age-old adage: if a tree falls in the wood, can you It doesn't make a noise. Does anybody hear it? Well, it turns out it does make a noise, and Chrome does render something, and it can be seen, but you just don't see it. So yeah, high level, this is essentially a quick, visual representation of what we're going after. Headless Chrome renders video. Video frames get sent to an end user laptop. That laptop then sends keyboard and mouse events back to Headless Chrome. So we're essentially just kind of like making a closed loop system here with events being propagated back and forth. So yeah, that's kind of where things are at for the high level. The first step, though, is we're going to get Puppeteer running in the browser. So that step is a little tricky. If you just import Puppeteer into the browser, you're going to get a lot of issues because Puppeteer has like very stateful file system related APIs. And if those aren't there, you're going to have trouble. But if you pull in packages via ESM, and we'll talk about that in a second, you can get Puppeteer running inside of a web browser pretty easily. And these are the two APIs that you'll need, two methods that you'll need to get that. And I'll show you why here in a minute, why that is. You'll also notice that we're pulling in directly from specific paths inside of node modules. This generally isn't a great practice, but we're doing something new and novel. And so we're going to break some rules. So be ready for that. The reason that we're doing it this way is Puppeteer natively has an ESM build. So ESM is an ECMAScript module. It's a module definition that works in most modern browsers as well as in backends. It's a little different than CommonJS, which is what Node uses and what things like Webpack tend to use. By only using connect, we don't have to polyfill anything. This natively will just work in the browser. And so there's less you have to bundle and make webified. Modern browsers also can just read this dependency tree and know to load subsequent dependents. So like, for instance, I'm loading in the browser WebSocket transport. That has dependencies. The browser will see that and load those natively. What that means is we don't have to have something like a bundling system running. We don't need Webpack. We don't need any like ESM builds, any of that stuff. This just natively works in the browser without any tools. So now that we have our dependencies, the next step in getting this video streaming capability working is having our user's web browser connect to the headless browser. Now, there's a little bit of magic that kind of goes on in here. We essentially need to have a headless browser running with an open WebSocket debug port, which is that browser WS endpoint. And then we pass it the connection transport, which is the WebSocket connect transport, which is the first line. And then we have some options. I will mention, by the way, that this is all in a repo that is public. So if you want to see everything in full context, it's there because there's quite a bit of code. But this is essentially the highlights and things to think about when you need to do things of that nature. So now that we got this up and running, we have a full-blown browser object in the browser. Yes, you heard that right. We are automating a web browser with yet another web browser. It's all JavaScript top to bottom, up and down, left to right. Most of Puppeteer's API is available, except for the file system stuff. So you're not going to be able to generate PDFs probably with this. You're not going to be able to do screenshots or save to the file system or load extensions. That kind of thing is mostly meant for a backend system like Node or Java or any other server-side language. This is, again, running in the browser's JavaScript context. The most important thing to highlight, though, is we now have full access to the Chrome DevTools protocol. And what that means is we can talk to a layer lower inside of Chrome and actually get APIs that maybe Puppeteer doesn't have. So if you think back to Matthias's talk earlier, there's WebDriver, which is like a super high level library that talks to old browsers. There's Puppeteer, which is kind of a level lower, closer to just Chrome and Firefox as well. And it talks to those specific CDP browsers. Then the lowest level at this time is Chrome DevTools protocol, which we're going to use because we need to get access into some pretty novel and new APIs. Chrome DevTools protocol is very noisy, and it was mentioned in an earlier talk that it's very difficult to sort of navigate sometimes, and things break very frequently in there, and it's not based on any sort of standard. So be careful. Your mileage may vary. Things will break. They actually broke even in making this talk with some click handlers. So just be aware that this thing can be breaking at some point. So you'll always want to have good tests, if you can, watch the test video and see how to generate tests. And then that way you can have a good time with this. But I'm going to move right along. So like I said before, CDP, you get full access to Chrome and what it can do. It's not limited to any sort of high-level library. New features tend to emerge at CDP, and then they get implemented in higher level libraries. So you'll see probably a screencast feature come into Puppeteer at some point if it doesn't already, and then eventually it'll get up and even to WebDriver standards. Setting up CDP is really simple. We create a page. I apologize. Line 2 is kind of the backhanded way of getting the client. There is actually an API for getting a client that isn't calling private methods, but this has worked for a long time, but this is a way to get the CDP client that operates the page. And we're going to have a page go-to call that navigates to the URL for the users. So thinking back to our first slide, this is Gmail, let's say. All right, streaming images. This is the first bit of insider knowledge, let's say, to get this going. So you need to subscribe to screencast frame messages from CDP. What that means is that CDP will send you, the browser, a new screen frame every time it gets drawn. It is high frames per second, and it's very network heavy, so be cognizant of that. You don't want to run this on like a data phone, let's say, or a cell network. It'll just eat through your data plan. And then part 2 of that is we need to tell Chrome that we want to get screencasting frames. You can tell it a format and a quality. I tend to opt for JPEG just because it's a little bit lighter on network bandwidth. You can obviously do PNG. Quality here is just a value from 0 or probably 1 to 100, and it's just kind of an arbitrary quality indicator, with 100 being very high quality, 0 being very low quality. All right, this is where some of the magic is. And again, please refer to the repo because you'll get better context of some of this. But on every screencast frame, we need to acknowledge that we received the frame to Chrome. Otherwise, we may not get future events from the screencasting session. So we send CDP an acknowledgement that we got that screencast frame, and we essentially we essentially have a canvas context that will draw that PNG data into a canvas element. More on that later. Okay. So video streaming is pretty much handled at this point. We ask for Chrome to send us screencast data. It sends it to us in base64 encoded data, and we draw that on a 2D canvas context. Pretty straightforward, I think, at this point. Now comes the fun part. CDP has 2 APIs for doing keyboard and mouse events. There's a ton of options for both. If you think about all the different types of keyboard events you could send, you can be holding Shift, you can be holding Alt, Control, left, right, all these other modifier keys, as they're called, back. And for the purposes of this talk and this presentation, we're going to keep it really simple and just kind of try to unify it into one simple object. You're obviously free to do whatever you'd like, but we're essentially going to marry some DOM-based APIs with some CDP-based APIs and kind of have a translation layer that happens in between so they can be successfully mirrored back and forth. What does that mean? Well, we're going to have a lot of event listeners on the body. So we'll have key down, key up, and key press events. The reason that we have all those events is sometimes you'll have an interaction on a page where you maybe press and hold, or there's a pressure for like a touch. Think of your phones, things of that nature. So we need to have a lot of event handlers. Luckily, they all get transferred into the same handler itself. So this will kind of handle all those cases for us a little bit. At a high level, what this looks like is we essentially derive any sort of text that might be represented by that character code that you've sent. And then we have a big object here for what CDP understands about the code, if it's a keypad, if it's a system key, the identifier. I will let you refer to the CDP docs on this because it is intense. It's kind of a beast. What we have here and in the repo works, but it may not work for every use case. For instance, like pasting might be difficult with this type of implementation that we have. So it does take a lot of trial and error. You have to be a tinkerer by nature to kind of really enjoy this and get to it. But this is essentially the object that we're going to send, and the method that we want to send is the input dispatch key event to CDP. That will actually trigger the browser to literally mirror that key press natively. So it's a native, almost native key press event, almost like a real user actually touching that button or key press or whatever. All right. This is all of the event listeners we need for mouse events. So a lot. You want to be able to scroll. You want to have mouse enter and mouse leave. You want mouse down, mouse up. I don't have an event handler for pressure here necessarily, though some of that does come from the DOM. So take a look at that. This is the fun part. Again, going to have to be a tinkerer to really enjoy this. And similar to what happens with keyboard events, we construct an object here that has the button type, the click count, modifiers, XY coordinates. XY coordinates are really important for this. You want it to be relayed in the same spot on the underlying headless browser. And so what we do in the full repo is we draw the headless browser to be the same width and height as the end user's browser. And that way, X and Y coordinates map 1-to-1 back to the headless browser. And again, I'll have a slide here in a minute with where that repo is and a QR code if you want to do that, since we're all fancy with QR codes nowadays. But some of these static methods, all that will be in there. It'll be very clear and plain to see. Okay. Recap on this. We capture keyboard and mouse events. We dispatch the input dispatch key event and input emulate touch from mouse event CDP command. Again, I'll be really stressed and push this point home. These break, they change. DOM APIs change. Having great tests around this is really important, and it's very difficult to know when things are going to happen as they happen. So if this is too much, I would say even wait for like Puppeteer to have a native API for this, and that way you're not talking directly to CDP and you're kind of protected away from some of those intermediary breaking changes that tend to happen inside of CDP. The repo is here. I am almost out of time. Apparently, this needs a lot more diving into in technical discussion. So please ask your questions here. Happy to talk more about that. But yeah, some final closing thoughts before I get over to questions is, handling, we didn't talk about handling resize events. The repo does. That's really important for getting X and Y coordinates to get back to the underlying headless browser properly. Error handling wasn't shown in any of these slides, but it is a little bit on the repo. Having something like a server intermediary is really helpful. So handling things like auth, TTLs, things of that nature, maybe limiting what that user could do if they can navigate to certain pages. If they can't, the last thing I'll stress is this is like very, very novel, proof of concept-y almost. It's a lot of network bandwidth. You might consider moving over to a better network, like streaming interface of some kind, if you can. But yeah, that's about it.